All right, good evening. This is for pre-calculus. So we are going to be talking about the converting polar or we're going to be talking about converting complex numbers to polar form. Okay, so for example, if I have a complex number and I say z is equal to 2 plus 3i, okay, the first thing we're going to do here is put this on the complex plane. So I'm going to draw a little complex plane here. This axis is going to be my real numbers. This axis is going to be my imaginary numbers. So the y-axis is effectively my imaginary numbers. So if I want to do a complex number here, it's going to be 1, 2 in the real direction, 1, 2, 3 in the imaginary direction. So we're going to have our complex number like this. And if I draw a little thing like this, we have a triangle. Okay, so what we're going to do is this is Cartesian form. Okay, this is Cartesian form. Okay, and we want to convert to polar form. Okay, and what I want to do is I want to figure out the modulus. I want to figure out the distance between the origin and the point that we have here. Okay, so the distance between the origin to point P. So notice we have a triangle. We have a side here of 2. We have an opposite side here of 3. So we can use Pythagorean theorem and say, well, what's the distance between the origin to point P? And we're going to say, well, that distance, okay, or the absolute value, or the modulus of z, is equal to the square root of 2 squared plus 3 squared. Okay, so all we're going to do is get the absolute value of z is equal to the square root of 4 plus 9, and say that that is the square root of 13. Okay, now let's go ahead and introduce another complex number and say we have z2 is equal to, let's do with 1 plus 2i, 1 plus 2i. So again, we're going to go ahead and make a little triangle here. So we've got 1 in the real direction, and then 1, 2 in the imaginary direction. So we move a 1 to this point here. This is 1 plus 2i. Okay, so we've got to have a little triangle here. So if I want, we'll put little ones here. So we have z1s, okay, and we'll say the modulus of z2, or the distance between the origin and z2, okay, the absolute value of z2 is equal to the square root of, we have 1 on our adjacent side, so 1 squared plus 2 squared for our opposite side, and say, oh, this is z2 is equal to the square root of 1 plus 4, and we can get the square root of 5. Okay, so that's what we have for this. We're not quite done getting the polar form yet. The other thing we have to do is we have to get what angle does this make with the axis here. Okay, what is that theta there? Okay, what is this theta here? Okay, what is that theta? So what we need is a trigonometric ratio that relates the opposite side, the adjacent side, to the angle. So we can say something clever like the tangent of theta is equal to the opposite side over 2. This is for theta 1. Okay, or we can say something like theta is equal to the inverse tangent, right, of 3/2. I'm going to do this in degrees, okay, because that's going to make it a little bit easier to assimilate. Okay, and we're just going to go ahead and do that. So I'm going to bring up my calculator here. Okay, we're going to make sure that we are in mode. So I'm going to turn it on. Back to mode. And we'll go back down here and we'll say mode is going to be in degrees. So we've checked it for degrees, so everything is going to be working in degrees here for this problem. And we'll just say second function, tangent, and then say 3 divided by 2. All right. 3 divided by 2. There we go. All right, so that angle, 50, we're just going to do it in one decimal place for this. We're going to say it's 56.3 degrees. Okay, so my theta is, okay, my theta is 53, or 56.1 rather. Let's double check. 56.3. Okay. So 56.3 degrees. Okay, going back to my picture, okay, with my triangle here. Okay, what I want to do is figure out, well, if I just have this distance here, this absolute value distance and our angle, how do I get back to getting what my adjacent side is? Well, the adjacent side is going to be the adjacent over the hypotenuse. Okay, so if we go ahead and say, well, if I multiply the hypotenuse by this thing, then the x part of this thing is going to be, right, the square root of 13 times the cosine of 56.3 degrees. If we go ahead and do that arithmetic, so we can try it. Okay, so I'm going to say the square root of 13, okay, and my parentheses, times the cosine of 56.3. That's pretty close to 2. Okay, so that's what we're doing to get this triangle. But what I would really like to do is get the whole complex number. So the opposite side rather, we're going to put in an I, because we're going to remind ourselves that we want to go in the y direction here. So we're going to put in our I here, and we're going to say the sine, because we need to get what's the height of the triangle. And that's going to be the sine of 56.3 degrees. And if I double check that, right, we're going to say, hey, this is, oops, I don't want any of this. Okay, so it's second function, the square root of 13, and parentheses, times sine of 56.3 degrees. 6.3 degrees. There we go. We'll type that in, and we got something really close to 3. So if I just let this go as one expression, I could say, hey, this is approximately 2 plus 3i, right? It's just written as square root of 13 times the quantity cosine 56.3 degrees plus I sine 56.3 degrees. We tend to abbreviate that a little bit further. So we're going to say that this is the square root of 13, and then we say cis, cosine plus I sine. This is 56.3 degrees. And that's the polar representation of my Z1. We're going to do exactly the same thing with my Z2. Okay, so again, we're going to figure out, like, well, what's this angle? Okay, for Z2. So tangent of theta 2 is equal to, what is my opposite side? My opposite side looks like it's 2 up. So we have 2 divided by 1. So theta 2 is equal to the inverse tangent of 2 over 1. Okay, and a lot of times people tend to use radians for this. I'm going to just use degrees because I want to make this more intuitive kind of experience. So my angle is going to be inverse tangent. Okay, second function tangent. So we have inverse tangent, or arctan, of 2 divided by 1. Okay, let's put a 2 in there. Say that's going to be 2 over 1. Right, we got 64, and again, we're just going to go to one decimal place, so we're going to call that 63.4 degrees. Okay, so we have 63.4 degrees. So Z2, this is Z1, Z2 is going to be the square root of 5 times cosine of 63.4 degrees plus I sine of 63.4 degrees. Okay, or we could write this in the abbreviated format, and we could say this is the square root of 5 times cis cosine plus I sine of 63.4 degrees. Okay, and that's how we have our converted, or our polar, or complex number converted from Cartesian coordinates to polar coordinates. So that's not just the whole end of the problem. I mean, that could be one problem, but that's not a very exciting problem. So the next thing that we're going to do is say, well, how would we multiply this? Okay, what is z1 times z2? Now, if I just do it in Cartesian coordinates, okay, that's going to be 2 plus 3i, all right, times what's my z2? That's going to be 1 plus 2i here. Okay, 1 plus 2i plus 2i. And we just go through and FOIL this thing out. Okay, so our first, that's going to be 2. Our outers, that's going to be 2 times 2i, that's going to be 4i. Okay, our inners, that's going to be 3i times 1. These are all pluses. And then our lasts are going to be 3i times 2i. That's going to be plus 6i squared. Okay, 3 times 2 is 6. And then we have I times I. But one of the things we have to remember is since I is equal to the square root of -1, I squared is equal to -1. So we have 2 plus 4i plus 3i minus 6. Okay, so 2 minus 6, we collect the real part. That's just going to be 2 minus 6. That's minus 4. And then 4 plus 3, that's going to be plus 7i. Okay, so that's how we FOIL those out. Okay, if I wanted to look at this in the polar form, okay, actually we're going to convert this product, z1, z2, into polar form. Convert this to polar form. Okay, so again, we could draw a triangle. Okay, so we have to draw a triangle over here. So we're going to have in the real direction 1, 2, 3, 4 in the real direction, and then hopefully I left myself enough room. 1, 2, 3, 4, 5, 6, 7. So we're going to be over here somewhere. Right? And this is going to be my triangle here. Okay. So in order to figure out this distance from the origin to this point here, okay, we want the absolute value of z1 times z2. So what we're going to do is we're going to make this triangle. We're going to say, okay, well, that is the square root of -4 squared plus 7 squared. Okay, so we're going to have square root of, and we have 16 plus 49. Right, and that's going to give us the square root of, that's going to be a 7. That looks like, nope, that's going to be a 5. 9 plus 6 is 5, 15. So it looks like it's going to be the square root of 65. Okay, or I could say this is the square root. 65 is 13 times 5. Okay, like, why would I do that? Like, well, I know what the distance for z1 is, the square root of 13, and the distance of z2 is the square root of 5. Here we have it's the square root of 13 times 5. That comes from the fact that z1 had a distance of square root of 13, z2 had a distance of the square root of 5. We push them together, multiply them together, we get the square root of 65 here. Okay, and now we have to figure out, well, what is this angle? Okay, so the angle we have here, this theta here, well, it's related to, right? We need the reference angle. So what is the value of the reference angle here? So this is going to be 7, right? That's my opposite side. And then we have a -4 here, okay? So this is in the second quadrant, okay? So we have to be careful when we take our inverses because it's in the second quadrant. So tangent will be negative, but the inverse tangent is only going to give us something in the fourth quadrant. So we have to be careful. So my theta here, right, is going to be, or I should say the tangent of my theta here, okay, is going to be -7/4, right? So theta is equal to, and let's go ahead and check that out. So we want inverse tangent. Let's go ahead and write that down first. So we're going to have inverse tangent of 7/4. Okay, type that in. So we have second function tangent. Let's turn it on. Second function tangent of -7/4. -7/4. we have negative 60.3 degrees. We'll say, again, to one decimal place. So we ended up with negative 60.3 degrees. Yeah? All right. That's not really the angle we want, though, right? That's what arctan will tell us, but that's not the angle we want. That tells us this angle down here. Okay, this was negative 60.3 degrees. What I really want is this angle over there. Okay, but these are opposite angles. So what this is going to be 60 over here, but we have to add some to it. So we're going to say this is 180 minus 60.3 degrees. And that'll tell us what this value is here. That'll tell us what the theta is. Okay. So what's going to happen is we get 180 minus 60.3 degrees. 0.3 degrees. There we go. We ended up 119.7 degrees. Okay, so just to kind of recap, right, we're looking at this angle here, so that's this one here. This is 119.7 degrees. Okay, this value here, this is the square root of 65. Okay, so I'm going to go ahead and FOIL out the polar form to see what happens. Okay, so we go back up to our polar form. We have square root of 13. Okay, so we need a little bit of room to work with here. So we have square root of 13, and then I've got cosine, what angle? Cosine of 56.3 degrees. Plus I sine of 56.3 degrees. That's Z1. Times, and we're going to have times Z2, and we have the square root of 5. Okay, times, and we had cosine, and I'm going to have to go back up here and look. Okay, so what did we find out for this? This was 63.4 degrees. Okay, so this is 63.4 degrees plus I sine of 63.4 degrees. All right, so when I multiply these two together, okay, we have some FOILing to do. We could factor out the square root of 5, square root of 13, so it's going to be the square root of 65. Okay, and then we've got to multiply some stuff out. So we're going to have cosine of 56.3 degrees times cosine 63.4 degrees, right? So that's my firsts. My outers is going to be plus cosine of 56.3 degrees, so sine of 63.4 degrees. Okay, there's an I here. Okay, then we have plus, and we have I. Now this is my outers, so this is my firsts, this is my outers, my inners. Okay, that's going to be sine of 56.3 degrees, 56.3 degrees, cosine 63.4 degrees. Okay, let's clean that up a little bit. Right. Can I make this a little bit smaller? Kinda. Okay, not really. Okay, so this was my inner. So this is 56.3. Okay. And then my last, okay, I've got an I times an I. So I've got a minus because that's the I squared. Okay, I squared is -1. And I've got sine of 56.3 degrees times sine of 63.4 degrees. Okay, so if you're in my pre-calculus class at this point, I would ask you, because we've gone over addition of angles formulas for cosines. You remember what it was cosine of A plus B? And this was cosine of A, cosine of B, minus sine of A, sine of B. Okay, so look at this. We've got cosine of the first one, cosine of the second, minus sine of the first, sine of the second. That's cosine of a plus b there. Okay. What was sine of a plus b? Sine of a plus b was equal to sine a cosine b plus sine cosine, cosine of the first, sine of the second. Right? Cosine of the first, sine of the second, plus cosine of the first, sine of the first, cosine, and then, so like, look, a is here, and then we have a sine, same one. Okay, we might have to swap these around a little bit, write them in a different order, but that's okay. Multiplication commutes, we can swap the order, that's all right. Okay, but look at this, we just have sine of a plus b. So in order to multiply these, we're going to have cosine of 65, and then what we have here is cosine of, what's 56 plus 63? So I'm going to go back here, and I'm going to say, okay, well, I need 56.3 degrees to move this thing on. 56.3 degrees plus, okay, my other one was 63.4, 63, there it is, 63.4. We just did this to one decimal place, and we got 119.7. Okay, and if I didn't know better, I'd say we have 119.7 degrees right here. Look at that. Okay, well, we did the whole thing. So that's going to be cosine of 119.7 degrees plus I sine, right? Because this is the sum of the sine parts of there. This is 119.7 degrees. Okay, so in order to go through and multiply two complex numbers, we could go through and FOIL them out, but if they're already in polar coordinates, all we have to do is multiply the two moduluses together and then take cosine plus I sine and add the two angles, and that's how we multiply these guys out. Okay, so this is the same value that we got for the, when we multiplied this out with -4 plus 7i. Okay, so this is also equal to -4 plus 7i. Now, you might say, well, who cares? That's fair. One of the problems that I would give my intermediate algebra students is to multiply a lot of complex numbers together. So they would get practice FOILing and practice combining powers of i's, etc. So I might give them a problem that looks like 1 plus 3i, 3 minus 2i, and 5 plus I all together. We can keep going, right? And just have this string of things that you have to multiply. But rather than FOILing this all out, it seems delightful. What we could do is convert each one of these to polar, which isn't too bad, right? We could almost do this in our heads. This is 1 plus 9, so this modulus here is the square root of 10. 3 squared is 9, plus 2 squared square root of 13. 25 plus, what is that, 2i, so 25 plus 4, and get that one. And then we can quickly get the moduluses and then figure out, well, thetas are just equal to the inverse tangent of the y part over the x part. So theta 1 is there. Theta 2 is equal to -2 over 3. Theta 3 is going to be inverse tangent, right, of 5 over 1, sorry, 1 over 5. Okay, and we can very quickly figure out like what the polar forms of all these tiny problems are. It's going to be, and what we're going to do is we're just going to take all the different moduluses and multiply these together. So absolute value of z1 times absolute value of z2 times absolute value of z3, etc., as many as we have. And it's just going to be cosine of theta 1 plus theta 2 plus theta 3 plus I sine of theta 1 plus theta 2 plus theta 3. So if you have a lot of complex numbers that you have to multiply together, which never happens, not in electrical engineering anyway, Rather than going through and foiling all of these things out and making the mistakes that we could make and trying to figure out powers of I and all of that stuff, we convert them each individually to the polar form, and then just multiply the moduluses together, add the angles, cosine of all of those angles, plus I sine of all those angles, and there's your answer for all of those products of complex numbers. Okay, so that's what you would use this for. So thank you very much for showing up and tuning in. I hope this helps you guys with your homework, and best of luck. Thank you.